All right, let's go ahead and get our session here today kicked off. So thank you all so much once again for making time in your busy day to attend the session. My name is Eric, and I'm going to be talking to you today about getting started with Rust. So let's go ahead and dive into it. So a quick word here about training for programmers. We are a training company that is focused in on human-centered, AI-empowered training. So what exactly does that mean? So first of all, I've been doing corporate training now for the last 10 years or so for lots of big companies teaching corporate training classes, uh, covering a whole wide variety of topics, everything from Python to C# to JavaScript and TypeScript and React and Angular and Docker and DevOps and all types of different topics. And teaching those training classes is great, and it's great if you're part of a big corporation and you can attend those training classes. But if you're not part of a large company or you're looking to jump into programming, getting high quality software development training can be very cost prohibitive. So our goal here is to actually reach out to developers on an individual basis through training sessions like this one and even longer full day, multi-day sessions, and deliver training that can be affordable to everybody. So that's one of our goals here. Another goal that we have is that our trainings can be taken with a simple web browser and internet connection. So you don't have to have expensive equipment. You don't even have to have the best internet connection to be able to take the classes, leveraging things like GitHub code spaces and stuff like that to make it possible for literally anybody anywhere in the world with a computer and a basic internet connection to participate in the classes. We like to focus in on in-demand languages and frameworks. So one of the big reasons we're going to be talking about Rust today is because Rust is a quickly growing in popularity and usage programming language because of its memory safe features. Companies like Microsoft are starting to employ Rust in the Windows kernel. The Linux kernel has some code written in Rust. Also, various governments are promoting the use of memory safe languages to protect against cyber attacks and stuff like that. And so we want to focus this particular month in on Rust to help upskill people to start to learn more about this language and learn how to use it for the jobs that will be, coming out in the years to come. Another thing that we care about is empowering people to be able to work where they live. And what we mean by that is a person shouldn't always have to travel halfway around the world to find a computer job somewhere. With the internet and the ability to work remotely, for people to be able to get training where they currently live, have jobs where they currently live, support their families and their communities. That's one of the beauties of the internet. And so our goal is to help promote that as much as possible. And then, of course, the big thing that's changing in the world around us is AI. And AI isn't going anywhere. It's something that you can fight if you want to, but ultimately it's going to come to be a part of everything that we do in our day-to-day lives, particularly in the world of software development. So we're going to be taking a look at utilizing AI tools, not just to simply write code, but to help us learn how to write code. And so we'll be doing a little bit of exploring of that today as we go through our session together. We have a couple of additional upcoming training sessions this month and then right at the beginning of May. Next, not this Friday, but a week from this Friday, April 19th, we have a 6-hour class that we're doing on Rust for Python programmers. So if you have Python programming experience and you want to learn how to use Rust within the context of Python, that'll be the focus of that particular almost full day session. Even if you don't have Python experience, it'll still be worth it to take the class if you have the time and you're interested. Even if you can't commit to a full day on that Friday, if you register, you'll get a copy of the recording. So if you haven't done that yet, make sure you register for that. I'll give you some information at the end of today's session on how to do that. And then the next one we have coming up is going to be building web apps with Rust and Leptos. One of the big things that Rust can be used for is for doing WebAssembly programming. If any of you all have ever heard of technologies like Blazor for Microsoft, which is basically running C# in the web browser using WebAssembly, Rust can also run in the web browser using WebAssembly. And Leptos is a component-based framework similar to React, except you write all the code in Rust and it runs, well, in the browser. So we'll be doing a full day session on that on Thursday, May 2nd, if you have an interest in that particular course. That one does have a price for $10, but the other one next week is free. So if you have an interest in any of those, take a look at registering for them, and it'd be great to have you in those sessions with us. All right, so what's today's agenda going to be about? We're going to talk a little bit about what is Rust, setting up a Rust development environment. We're going to build a little tic-tac-toe game with Rust, among other little demos that we're going to do. And then we'll do a Q&A. If you have questions along the way, I would invite you to put those questions into the Q&A box of Zoom. For whatever reason, it seems like the chat is disabled. I'll have to go back and double check and figure out why that is later on. But if you have a question at all during the course of the presentation, put it into the Q&A box, and I'll try to keep an eye on those as I'm presenting. And then, of course, whatever I haven't answered, we'll take care of answering that at the end. I've planned for the sessions for today to go for about an hour or so, maybe a little bit longer than an hour. And so we should have plenty of time to answer any questions that are asked. All right, so let's talk about what is Rust. Let's start off first with this. If you could, raise your hand for me if you've done any Rust programming at all. So if you've ever done any kind of Rust programming, raise your hand for me. Okay, so nobody's raising their hand. Anybody here who's never done any Rust programming? You're totally new to Rust. Raise your hand if you're totally new to Rust. All right, very good. All right, very good. All right, so what's the big deal with Rust? Really, the big thing with Rust, more than anything else, is the memory-safe programming. In the world of computer programming, we really have two kinds of programming languages. We have what are called garbage-collected languages, which are languages where memory management is handled for you automatically by the programming language itself. Good examples of this would be C#, Java, Python, JavaScript, Go, those languages. Then we have the languages that require manual memory management, non-garbage collected languages. Languages in that category would be things like C, C++, Rust, okay? Now, the advantage to garbage collected languages, things like Python, JavaScript, Java, is that the developer is not responsible for managing memory, which means the developer doesn't make mistakes causing memory leaks and other problems. In manually managed language or manually memory managed languages like C and C++, you always hear about the stories of all types of different bugs related to memory management and how hard it is to write programs that don't have a bug somewhere in terms of memory leaks and things like that. The reason, though, that people like to use manually managed or memory managed application or programming languages is because you get better overall performance. You have control over how that memory is being freed. In languages that are garbage collected, they kind of behave in a non-deterministic way when it comes to memory management. Whereas in these languages with manual memory management, you control when that memory is freed. And if you're writing things like operating systems, real-time software, so on and so forth, having that level of control can be a big deal. So what does Rust do? Well, Rust basically tries to give you the safety and protection of a garbage collected language, but it tries to give it to you without having to have a garbage collector. Essentially, what Rust does is Rust builds into the compilation process all of the memory safe stuff that you're going to need at runtime. Because of that, it enforces a lot of extra rules on top of how you write your code. And that is one of the reasons why Rust is so hard to learn, is it's dealing with all of those extra rules that are applied on top of your code at compile time, rules and things that you have probably never even really thought about before, unless you really have done a lot of C++ or C programming. But especially if you come from a background of working with Python or Java or C#, some of these things are things you've just never even thought of before. And yet when you go to write the most basic Rust program, you end up bumping into all of these memory issues in terms of how you manage things. So that's one of the big challenges of working with Rust, is working in that memory safe environment, yet it's like the reason why we use Rust. Rust is also well known for being able to do concurrent programming very, very well also. Now, other languages can also do concurrent programming. That's not really uniquely a Rust thing. The memory safe part is what really sets Rust apart. So to kind of summarize here, Rust is a systems programming language focused in on speed, memory safety, and parallelism. Okay. It employs a unique ownership model to manage memory without a garbage collector. So it wants to give you the safety of a garbage collector without the penalty of one. And it does that by building into the compiler those rules for making sure that you're working with memory in a safe kind of way. Rust provides a powerful type safety and error handling features to prevent common bugs. It supports zero-cost abstractions, allowing high-level features without performance penalties. For example, in languages like Python, you have a lot of abstractions, but they're not zero cost. The more abstractions you throw into your code, the higher the penalty is for using them in terms of performance. Rust tries to eliminate that with how it provides its abstractions. Rust is used in a wide range of applications, from web servers to operating systems to building things with WebAssembly, as I was mentioning before. Now, when you typically think of, let's say, a systems type language, you really think of just building out operating systems or other low-level device drivers and other things like that. But Rust is used, like I said, for building client-side web apps with WebAssembly. It's also used to build REST APIs, right? So it can be used for all of these different purposes. It's not limited just to programming the next operating system. So that's kind of one of the cool things about working with Rust. Okay. What we're going to do now is we're going to jump over to our editor, and we're going to explore working with Rust for the rest of our time here together. After all, we're all programmers. We love to write code. Nobody wants to watch a slide deck. So let's jump over to the actual code stuff we're going to be working with here. So the first thing is, I have a GitHub repo that I'm going to give everybody the link to here. Let me put that into the chat. Can everybody at least receive chat messages? Can you get the chat message in the chat? Raise your hand if you're able to see the link that I put into the chat. Okay, awesome, perfect. Go ahead and click that link for me. Now, what I've done here is I've set this up using a GitHub code space. So if you can log into GitHub and you haven't used up all of your free code space hours for this month, then you should be able to come into the repository here and click create code space, and it should create the code space for you. Once it does that, the code space will look something like this one right here. In fact, let me go ahead and restart it. It'll basically be VS Code running inside of your web browser with all the extensions and plugins and Rust already set up for you, so on and so forth. So if you click on this link and then click on code and click on code spaces here, go ahead and click create code space. I'm going to do a little bit of talking here at the outset, so you'll have some time for it to build your code space, and then you'll be able to code along with me. I've set up the big demo and everything so that it's something that you can actually copy and paste and follow along with me and actually practice writing some Rust code. Okay, so let me kind of talk a little bit about the environment here first, because much of this would be the same thing if you were doing, let's say, Rust development locally on your system with VS Code, because this is literally VS Code running just inside the web browser here on GitHub. So let's start off here. You'll notice I've got a dev container folder. This dev container actually defines the dev container that's running inside the code space. There's a little Docker file here that sets up the environment. What you can basically see here is that we're using the curl command to basically install Rust up, which can then be used to install Rust, update your tool chain. There's the regular release and then the nightly release, so on and so forth. If you go over to the Rust website, you can read all about the installation process for your particular machine. But I wanted to point out the Docker file in case you wanted to see the actual commands that are being used to set up this actual development environment here. In the dev container JSON, you can see the extensions that we have installed here. This first extension that we're going to be using is the actual, Rust language extension that you would use in VS Code if you want to do Rust development. Also, we have this LLDB extension installed, which allows us to debug our Rust application. So you really need both of those. And then I've got both Copilot and Copilot Chat here installed in my editor as well. If you have a license for Copilot and you run this code inside of a code space, it should pick up your license and you should be able to use Copilot. So if I come over here and click on the little Copilot Chat, you'll see it picks up the fact that I'm logged into Copilot here. And the rest of these are just some editor configurations for how I like to write my Rust code. You can take a look at those on your own time. Okay, now down here, close that. I have my terminal window. If you don't see a terminal window in your environment when it fires up, you can click on the little menu over here, go to terminal and click on new terminal, and that'll open up a terminal window for you. Now, inside your terminal window here, you can type in Rust C version, and it'll show you the version of Rust here that I have installed, okay? So the actual Rust compiler and all of that cargo is already installed for us and ready to go. Over here in my list of extensions that are installed, you can see these are the ones I just showed you in that other file. And there's the list of extensions there that are ready to go. Okay, so we're going to get started here by creating kind of a hello world style application, just so we can kind of do a little bit of exploration using some Copilot, using a little bit of Rust. And then after we do that for a little bit, then we're going to dive into our formal demo that I've put together for you here. One of the big things that I've been teaching a lot of actually are GitHub Copilot classes. And while GitHub Copilot is definitely a great tool for being able to do just your day-to-day software development, Copilot is also an amazing tool for learning new things. Raise your hand if you're using Copilot as part of your day-to-day work right now. Anybody using Copilot as part of their day-to-day work? Cool. Yeah, if you haven't checked it out yet, You really should. It really is. It's a great tool. It's well worth the money. If your employer doesn't pay for it and you're just an independent developer doing your own thing, it's well worth the money. Just the things that it can teach you is really incredible. So let's go ahead and get started. In the world of Rust, when you want to create a new project, you're going to use a tool called Cargo. Cargo is kind of similar to like Maven or NPM or NuGet or PyPy or Conda that you would see in other languages. It's used to install what are called crates, which are basically code libraries. It's also used to create new projects, to run your project, so on and so forth. So I'm going to come into here and make that a little bigger so it's a little easier to see. And I'm going to run the command cargo new hello world. We'll create ourselves a little hello world program here real quick. So you'll notice here, it creates a folder called hello world. And inside of it, you have a source folder and a main RS file. So RS is the file extension for a Rust file. You'll also see that we have a cargo toml file. This is where information about your project, also known as a crate, information about your project is stored. So if we were using third-party packages and installing them, or third-party libraries and installing them, you would see them listed in this cargo toml file. But we'll go ahead and close that real quick. And let's come back over here to our main RS file. Now down here, what I'm going to do is I'm going to say cargo build. Oh, let me change into my hello world first. Make sure you change into your hello world file. Then you can run cargo build. And you'll see that it's going to go ahead and build our project. You'll notice that when it builds, it locks down the cargo lock file. So if we had a bunch of dependencies and stuff, you'd see the locked versions in this file. You'll also see a target folder created. And inside the debug here, you'll see there's our hello world program. An easy way to run the program is to actually just say cargo run, and it'll actually run your program. And you can see there we have hello world. Okay. You don't have to manually build before you run. You can actually just say cargo run. And if a build is needed, it'll automatically build for you. So for the rest of the demos, for the most part, I'll just be saying cargo run, and it will do both the build process and actually running the code. Let's take a look here at the file that it created here for us. So we have a function here called function main, just like other languages you've made use of before. There's a main function. One thing you will find interesting is that this main function is not wrapped inside of something else. If you have come from like a C# or a Java background, you're familiar with having to have some type of class and then the main functions inside the class. That's not the case with Rust. In fact, Rust doesn't even have classes. But this is just a simple standalone function, kind of like what you'd see in a C program for starting off the application. Here we have a print line. Now, what's interesting with Rust is Rust has this very awesome and extensible macro system. Okay. Now, we're not going to go into the details of how to create our own macros or anything like that in this particular training that we're doing now. We're just going to make use of the print line macro. But whenever you see a function like this that's got this exclamation point as part of the name, you know that you're working with what's called a macro. Okay. You could kind of think of the macro as kind of like a preprocessor. It's much more than that. But if you're familiar with the C or C++ preprocessing system, you could kind of think of it that way if you wanted to kind of help relate it to other languages. But it's a lot more powerful than just the preprocessing stuff built into C and C++. Okay, so we have our hello world function. Let's go ahead and write a little bit of code here to do something interesting. So what I'm going to do is I'm going to come into here and I'm going to delete our print line. And I'm going to put a comment here. And I'm going to say, declare an integer variable and assign it the value of 2. Pretty cool, right? Now, granted, I typed out a whole sentence there to get a pretty short line of code. But if you had never worked with Rust before and you were trying to learn this on your own and you were trying to leverage Copilot, you could type out a simple sentence like this, get yourself an initial line of code to work with, and now you're starting the process of learning. Okay. So like I said, we're going to do a little bit of exploration here with the AI and Rust, and then we'll get into our larger demo that we're going to do with tic-tac-toe. All right. Well, what if I wanted to print the value of X? There we go. So once again, there's our print line macro. And you can see that we have our string, and then we've got our string interpolation going on here. So the X here is going to be displayed right after the colon here at the end of the sentence. So if I came down here and said cargo run, you can now see the value of X is going to be 2. Pretty interesting. Now, let's say I called this twice. So I'm calling it once on line 6, and I'm calling it again on line 8. Let's run our code and see what we get. We get the X is equal to 2. No big deal. All right, so I'm going to come into here, and I'm going to say X is equal to 4. Let's run this. We have a problem. And this is where we start to run into some of the difficulties of working with Rust. In pretty much any other language that you would work with, when you declare a variable, you would be able to modify it. Now, I realize some languages like JavaScript have the const keyword. I think in Swift, let is actually used for constants in Swift as well. But generally speaking, when we think of using a variable like with Python or C++, Java, C#, those variables are generally mutable. Rust, out of the box, all of the variables are immutable. This is part of controlling how memory is being managed by Rust. Okay. And so this is where you start to run into these little difficulties where you're like, well, I want to be able to change that value. So let's come into here and let's do this. I'm going to come down to Copilot. We'll say fix this. Okay. So it's going to introduce to me a new keyword called mute, which is going to allow this variable to be, well, mutable. So I'll go ahead and view the changes it's going to make. It's basically going to eliminate those 2 lines of code and then add in these 2 lines of code. I'll say accept, and let's see if our code works now. So we'll go ahead and say cargo run, and you can see now the value of X is equal to 4. So right there, we were able to use Copilot to teach ourselves a few basics about the language. And now we were able to use Copilot to fix a bug. Now, could we have gone to the documentation and kind of worked through some of this just by reading the docs? We could have, but we were actually able to stay in the editor and do our coding here without having to be pulled out to go search on the web for something. Think about all the times you've been working on a project. You had to go look something up in the browser, and before you know it, you're getting distracted by a news website, social media, something like that. Here, we were able to work through all of our issues in the editor. Now, is Copilot a substitute for actually reading the documentation? Of course not. You are going to want to read the docs for Rust. You are going to want to read the Rust book. But for getting started and getting a little bit of code up and running, building a little bit of confidence, kind of enjoying the discovery process, The AI really helps a lot for that. Let's take a look at one more little thing here before we jump into our main demo. Let's say, for example, I wanted to have some type of data structure to capture a point, like an XY type of value. I could come into here and say, data structure to store a point value with X and Y coordinates. All right, there we go. Struct point. Structs are what we use in Rust to create a data structure. Rust does not have classes like you would see in C# or Java. Instead, it uses a struct for the actual data structure. And then it has what you would call an implementation block that allows you to connect methods or behaviors to that structure. We'll see some of that in the tic-tac-toe demo that we're going to be doing here shortly. But for right now, I just want to create a struct there. So I'm going to come down here to main, and we're going to update this code. And I'm going to say, create a new point with X and Y coordinates of 2 and 3. There we go. So to create my point, I have my let P. I have my point with my X and my Y. And now I can do something with that point. So maybe I would want to print the X and Y coordinates of the point. And there we go. Okay, so now I can print that out. I could even copy this and call it twice. Come down into here, run my code, and there's my X and Y. Now, this is another tricky spot we get into with Rust. And this is probably something you haven't really thought about before unless maybe you've done some C or C++ coding. I'm going to highlight this, come back over here to my Copilot chat. I'm going to say hashtag selection. In Copilot chat, you can actually tell it what to reference when writing code for you or giving you suggestions. And I'm going to say here, I want to move this code to a function named print point. Let's see what it comes back with. Sure, you can create a function called that. There we go. So now what I'm going to do is take this function here. I'm going to paste it into here, but I'm going to make one little change to it. Now that change I made is going to be a big deal here in a moment, but I'm going to remove the code for a second. I'm going to remove the ampersand because I want to show you something interesting here about working with Rust. So I'm going to come back into here and I'm going to say print point P. And this is going to print this out from the print point function. I'll say cargo run. You'll see it prints out my point one time. No big deal. Now what I'm going to do is I'm going to take this here. I'm going to call this function again. All right. Watch what happens now. I get an error. This is another one of these examples, another one of these struggles that you'll have when you get into Rust. Why can I not call print point a second time? I mean, you saw a few moments ago, I was able to call print line twice and print it out twice. What's so special about this function that I can't call it twice? And this gets into the whole concept of memory ownership. You see, when we created this point data right here, this function, this variable here owned that data. It owned that memory. When we called print point here and we passed in the P into here, this function took ownership of this data, which means that when we get to the end of this function, this data is freed. So when I called print point here, Sure, I still had that variable, but all of the data that it was connected to, all of that is gone. And that's because ownership was transferred from the main function into print point the first time I called it. Now think about that for a moment. Think about all the times you might have passed an object into a function. Did you ever think about who really owned that object? Was it the function you called from, or was it the function you were calling? Did you ever try to manipulate or mutate that object in some way? Did you even think about who had the ownership of it? In Rust, that's like the big thing. It's that memory ownership, which all ties into memory safe programming and properly cleaning things up. So in this case, when we called it like this, it took ownership. But what if I don't want it to take ownership? What if I just want to give it a reference to basically kind of borrow, but not actually to take ownership of it? No problem. That's where the ampersand comes in. So if I put the ampersand on both the type definition of the function parameter, I also apply the ampersand here in front of the variable that I'm passing in, and now I run this. Now it works perfectly. Now let me ask this question. Raise your hand if you think this could be very confusing if you were learning this for the first time. Anybody think this could be really confusing by a show of hands? I remember the first time I learned it, I thought it was confusing. And the reason is because I don't really think about memory like that when I'm working in a garbage collected language like Python or Java or C#. These ideas are not things we really consider or think about. The closest thing that I've come to, and let's say just modern business programming where people think about these kinds of things, is when you're writing things like React components. Anybody here ever done React programming by a show of hands? React.js, building UIs with React. You know how in React, when you call a React component, you can't mutate props? You know how props are immutable? That's the closest thing I've come to where I think about the ownership of memory in terms of just modern business development. Now, if you do C++ programming, even though C++ does not have a formal ownership model, there are lots of ownership patterns and things that people think about in C++ programming. But in JavaScript, Java, C#, we just don't think about those things. But if you do React programming, then you've encountered that idea of props being immutable and who owns the data. It's very similar to what we're doing with Rust here, okay, in terms of the thought process that we're having about that memory. Okay, is it necessary to learn C++? No, it is not. You can learn Rust just fine without knowing C++. Now, if you have C++ knowledge, what that gets you is it helps you understand the problems that Rust is solving. So if you're coming from Java or C# and you encounter Rust, at first it feels a little overwhelming because you don't really understand why Rust is solving these problems. Like, why is this memory ownership thing a big deal? If you have a C++ background or even a C background, you'll have a better understanding of why Rust is solving these problems. Okay, great question, by the way. All right, let's go ahead and jump into our bigger demo. I wanted to kind of show you these things a little bit to kind of give you a little bit of a taste for what Rust kind of is a little bit different from other languages. But let's go ahead and put together a little tic-tac-toe game. Now, there's going to be a lot of code here that I'm not going to spend a lot of time talking about. We only have the hour together. I wanted to give you something interesting to kind of look at, not just a bunch of little random demos, but it also means there's going to be code that we're not going to fully discuss. If you were to take one of the other Rust classes coming up, a lot of these ideas will be covered in those Rust classes. But for our time together here, we'll just do a little bit of a high-level demonstration of something kind of interesting built in Rust. So to do this, what I'm going to do is come back over to here. And I'm going to expand out the tic-tac-toe project. Okay. Now the tic-tac-toe project just has the main RS file. What's cool about this though, is I've configured this tic-tac-toe project to actually use the debugging capabilities over here. So for example, in launch JSON, you can debug your tic-tac-toe project by clicking here and clicking the little play button. You can also click the little debug button here as well. So if I come into here and click on this, and I click the little play button for the tic-tac-toe, it should hit our breakpoint right there inside of VS Code. So as we work on the tic-tac-toe, or you work on this outside of our session together, you do have debugging capabilities set up for the tic-tac-toe project. And you could set up similar ones for the other project we just did. You just have to go in and modify the launch JSON file. Okay, so the way this is going to work is I've got a demonstration script that we're going to walk through. This will enable you to copy and paste and code along with me. And then also I've already got the final version is over here in this file, so you can go take a look at the final if you want to. But we'll walk through this here and put together a little tic-tac-toe application. Now, the way I'm going to do this is I'm simply going to copy the code over. I'll do a little bit of explanation, talk about what it's doing, and then we'll move down to the next step. Okay? So we're going to start first by copying this over into main RS. I'm going to put it here near the top of the file. Let's talk briefly here about what's going on. So first of all, we have struct player. Essentially, we're going to have a tic-tac-toe game. We'll have 2 players. Each player has a name as well as a mark, which would be either an O or an X for playing the tic-tac-toe game. Here we have an implementation block for the player type. This allows me to define behaviors that are connected to the struct. So the implementation on the struct are two separate syntax structures. It's not like a class where everything's kind of put together. They are separate, but this implementation player is tied directly back to the struct because of the type name that you see here. Now, Rust does not have actual constructors for creating these objects. However, a common convention in Rust is to add a new function to your implementation, and you call the new function when you want to create a new object in memory. We're going to call them objects to create a new player object in memory. And here we receive 2 parameters, and then we assign those parameters here as part of creating the new instance. Now, let's come back over to here and let's create our board. So we're going to play tic-tac-toe, which means we're going to have a board with 9 cells in it. So here you can see I've got a struct board, and I'm going to basically create a 2-dimensional array of 3 rows, 3 columns of type char, which will just have the mark for the player who puts whatever mark on the board. And once again, you see that same pattern of creating a new function to create an instance of the board here. All right. We're also going to have a game object. So we have, for a game, we have the first player, we have the second player, we also have the board. But what's interesting is take a look at how we initialize all of this. So down here, to create our new player, we're going to basically say player, : and call the new method on it. And that new method, we pass in a player 1, and then we pass in mark 0 and mark X. Now, you might be wondering, why do I have this string player 1, and then why do I have a .toString? Like, what's going on there? In Rust, we have what are called string slices, and then we have actual string objects. String objects can be mutated and changed in memory, okay? So long as we have a mutable reference to it. A string slice is like a read-only slice of this string in memory. Whenever you create a new string like this, its default is to be a string slice, not to be an actual string object. And so what I'm doing here is I'm taking this string and converting it to an actual string object and then passing it in up here. Now, the reason why I'm doing that actually gets complicated. If I tried to use a string slice, it would make managing the memory lifetimes of the different data values, it would make that a lot more complicated. So for the purposes of our little demo, I'm converting it to a string to make this code up here a lot simpler. But if I were to try to simply just pass in the string slice, there would be more involved to ensure that memory was not released when it shouldn't be. And then, of course, I'm creating a new board right here. So now we're going to come down here and we're going to put in our game equal to new game. And I'm going to show you a very interesting feature in Rust. This code is not going to compile. It's going to fail. And let's see why. I'm going to say cargo build and watch what happens. Well, actually, we change into the game first, then cargo build. Okay. It generated a bunch of warnings here saying that these fields are never read. Field cells is never read. We have some dead code in here, right? Code that's never really used. So one of the things that Rust does as part of its compilation process is it's extra strict. If you've got variables that aren't being used, if you've got struct members that aren't being used, you have functions defined that are never called, by default, the Rust compiler will complain about that. Now, when you're doing development, sometimes those warnings can be really annoying because maybe you're in the process of building things out. You know there are some variables you're not quite using yet, but you've declared them. So what we can do is we can add this code right here to the top of our file. And this is going to provide some compiler directives to tell it not to complain about unused variables or dead code. So now if I say build, everything builds for me. Now, of course, you'd want to, you only want to use those for development purposes, but it'll make writing our code here easier as we're adding in functionality. Okay. Now, we should be able to run this, although it's going to literally do nothing. So we'll go ahead and run it, though. All right, now let's go ahead and add some code to display the game board. So we have a function here called display board. I'm going to copy this code right here. I'm going to put this over into my, let's see, we had that in the game? Yeah, game. Put that down into here. And I want to point something out to you here. And this needs to be, whoops. All right. Okay. In fact, I'm going to copy that real quick back over to here. There we go. Okay. Now take a look at these two methods here. Notice in the function new, there's no parameter here. But in the display board, we have a parameter here called @self. Okay. This new was invoked by using the double colon syntax right here. This display board is going to be invoked off of an actual object that we've created with that struct. So down here, for example, we're going to and you know what? I need to move display board sorry about that. We need to move display board actually up into the board implementation. I knew something looked a little off there with my code. Let's drop that in there. And then I can get rid of that. So go ahead and move your display board up into the board implementation and then change that self.cells back to self.board. And I'll fix the instructions as soon as we're done here. And then that way, if you want to go back later and walk through it, you can. Okay. So down here, notice when I call display board, it's game.board.display board. So when I'm invoking this, I'm not using the double colon. Instead, I'm calling it like a member method like you would see in other languages. So if we're calling what you might think of as kind of like a static method in something like a C# or a Java, new is kind of like a static method that we are using as like a helper method to create the instance. And this method is more like an instance method that we're using to actually display the board on the screen. So if I were to come down to here and I were to run this, you'll see now we have our board being displayed on the screen. Okay. And the change that I made here was this should have said board. And we should not have the word board here. And you can see I had updated it there. I just forgot to update it there. Okay. So now what I'd like to do is actually allow the players to type in their names. To do that, I'm going to need some additional functionality. I'm going to need to give it the ability to capture input from the user, and then a couple of little convenience methods here for setting the player name. So I'm going to copy this right here. I'm going to come back over to the game, and we'll drop that in. And then we're going to, let me get this method here. Okay. Now you'll see here, I have a red squiggle for flush, and that's because I need to bring in my standard IO write. So I'll go ahead and pull that in, and that should take care of that. Up here at the top now, we have a using standard IO write to bring in, other parts of the standard library into our project. Now, this is where things start to get complicated memory-wise. Remember, we talked about the idea of variables being immutable, or you could make them be mutable with the mute keyword. We also talked about the idea of passing references in and doing borrowing instead of transferring ownership. Well, that's what you're going to see going on here. Up here, this was simply borrowing a reference. This is borrowing a mutable reference. In order for me to update the data through this struct, I have to set this up as a mutable reference. I can't do this assignment with just a plain read-only reference. I can only do this assignment if I actually have a mutable reference. So one of the challenges you'll have when you get into Rust is really getting into this idea of mutable versus immutable, transferring ownership versus borrowing. When you do borrowing, you can actually have multiple read-only references, or you can have a single mutable reference, but you can't have multiple mutable references. In fact, because you can't do multiple mutable references, it makes implementing things like a linked list inside of Rust very, very hard to do. Anyways, this will set our player name. So I'm going to come down to here. I'll grab this code right here. Oops. Paste that in. And then come down here and run this. And I'll say Bob and Tim. And now we have Bob and Tim showing up on our little game board. Okay. Let me briefly speak about the way that we're actually reading in data here. So you see how we create an actual new string object, and it's a mutable reference to input. We print out, notice this is print, not print line. We print out the prompt to the user. In Rust, we have to tell the IO system to flush the stuff we've printed out before we actually do the read line here. And then you'll notice here, what am I doing? I'm passing in one of those mutable references so I can populate the input here. Now you'll notice these calls to unwrap. Unwrap is part of the error handling system within Rust. Rust uses a bunch of enums in a variety of ways. One of those ways is through the use of error handling. However, if you don't want to set up the whole enum mechanism, you can use unwrap. But what happens is if this flush operation fails or the read line operation fails, when you call unwrap, because of the failure, it'll throw a panic and end the program. We're not going to get into all the Rust error handling as part of what we're doing today, but Rust error handling, the right way to use unwrap, the right way to use the error enum and all of that, that's a big part of working with Rust, is making sure you're doing your error handling properly. I am going to show you an example of some cool enum stuff, but we're just not going to do it in regards to the error handling for this. Okay. We need to allow the user to be able to type in their move to place their X and their O. So I'm going to go ahead, copy this, and I'm going to paste that into our game down here. So now we can collect player input. All right, so we have a question. What's the difference between self and self? Yeah, no problem. Let me explain. That's a great question. So this self just represents basically the instance that we're working with. So if you think of like an instance method on a class, this self is the equivalent to this. Or if you've used Python before, self is that instance of the object. The self that you see up here, this is used to actually create the object, and I'm returning the object. So this self here is a parameter. This self is the actual data type, and I'm creating an instance of that data type, if that makes sense. Okay. All right. So we have our player input, and let me come over to here. I'm going to introduce this loop here into our code. So down here, Rust has an infinite loop, literally just called loop, and it will basically run forever until you break out of it or continue within the loop. And so we'll come down here and let's run this. And we'll say Tim and Bob. I can type in some input. Sorry, it's acting a little weird here. Let's try that again. There we go. So essentially, it gets the player input, and what it's using here is what you might call unpacking or destructuring of basically a tuple into these individual variables. So if you've ever used something like a Python or a JavaScript, even C# supports this as well. You'll see a lot of those kinds of language features available in Rust. Rust is very much a modern language. It leverages a lot of the syntax benefits that you'll see in these other languages that you've probably worked with before. Okay. Let's go ahead and I'm going to grab the code here for checking for the win. I'm not going to walk through all the details of this. This is all pretty easy to read through. It's basically just code checking to see whether or not someone has won the game yet. And we're also going to have the code for checking a tie as well as making a move. And so this is all going to be part of the board. So I'll go up to our board code. Now, one of the things we would cover in a Rust class is how do you break all this up into different files? We're not doing that for today's demo, but that's one of the things you would learn about. I do want to highlight this syntax here. You'll notice all of these lines have semicolons except for the last line. On the last line of a Rust function, you can put an expression, and the result of that expression is the return value. And you don't put a semicolon, and you don't put a return statement. If you need to return earlier in the code, you can use a return statement followed by a semicolon. But if you're just going to evaluate some expression and then return the result of that, you can do that there. Now, let me grab this code here, and we'll talk about this here for a second. So, as I mentioned to you, Rust makes use of enums. And let me drop this into here. And I'm going to grab one more piece, this part right here, to initialize. Okay. So Rust makes heavy use of enums. I know all of us have used enums over the course of our programming careers, right? It's one of the fundamental structures that you learn about in really in any programming class. But a lot of us don't really make use of enums that much. We don't really realize the power of them. Well, in modern programming, in languages like Rust, or if you've ever used Zig before, Zig is a kind of a drop-in replacement for C. It's another cool language you should definitely take a look at. Enums are heavily used. They're used for handling situations where you may have an output or you don't. Like if you want to have a really nice way of handling the possibility of null, enums are used for that. You can use enums for handling error situations. In this case, I'm going to use an enum for tracking which player is taking their turn, what the game status is. You might be wondering what this is. With enums in Rust, you can actually have an enum value that actually captures or outputs additional data, like a player. So if the game status is win, it can also tell me which player won the game. Pretty cool, right? Well, we're going to have a turn player here, and I'm going to copy some code here, and we'll take a look at how taking a turn looks. Now, remember, the intent of this is for you to go back later and spend some time reviewing the code, playing around with it, making changes, kind of exploring it, okay? Let's take a look at this. This is kind of interesting. Self.board check win, let sum winner. What did I say up here about win? With win, you can get back player information, right? If the person wins, you can know which player actually wins. Well, down here, when we call check win, if we get back a winner, then we're going to return back a game status of that winner, okay? If the game is a tie, we're going to return back game status tie. Here, we're going to return back which player is taking their turn. Or first, we're actually going to set that on there. And then here, game status would still be in progress. So just kind of pay attention to how we're using these enums, and then check what we're going to do down here at the end. Down here at the very bottom, we're going to use the match statement. The match statement will allow me to match the possible enum values against the return value from process turn. So process turn returns game in progress or game status tie. or game status win populated by the player that won the game. Well, down here, game status win, I can access that player information and display it like that. You see how powerful those enums are, how useful they are? It's not like a traditional enum you'd see in an older programming language. These things are really, really, really powerful. So when you get into Rust programming, in addition to learning a lot more about memory safe programming, learning how to work with things that are not classes, you'll also be learning how to make use of enums in new and exciting ways. And like I said, the same thing also applies to the Zig programming language as well. Anyways, if we run the code here, we should be able to say cargo run, Tim, Bob. It is zero-based rows and columns. So if I say 0, 0, I get a 0 there. If I say 1 and 1, I get an X there. 1 and 0. If I do 2 and 1, I get X. And then if I do 2 and 0, Tim wins the game. So the game actually works, right? So what would be some good ideas that you could pursue on your own following the webinar if you wanted to go deeper? Well, obviously, you could go through all the code and make sure you understand what it's doing. So for example, you could come into here and you could, let's say we took this piece of code right here. I could right click this. It'll let me right click it. Copilot, explain this. And you can go through and have Copilot explain the code to you. Right? So pick a line of code, have it explain it, go deeper in your understanding. That would be probably the first step. The next step that I would do if I wanted to go deeper is I'd ask myself, how do I break this apart into multiple files? This file's starting to get pretty long. It'd be cool if we could break this out into a game file, a board file, or a player file, modules, right? And be able to configure that. So that would be kind of the next step that I would do in looking to improve the code. Another thing that I would look at doing is properly handling all of these unwrap statements. So take a look at how to actually do the error handling correctly in Rust to handle those unwraps. You could also take a look at doing unit testing. Rust has unit testing built into it. You could take a look at how to do that. And that might be the next steps that I would make in trying to further enhance and improve the program. Before we wrap things up here, under the docs folder, I do have some documentation that I've provided you with in Markdown format, explaining some of the things that we talked about here. Ownership, some things about traits, if you want to take a look at that. You can take a look at those files there. Also, the repository will stay up here probably forever. So you can come back to here. This is a really convenient way to fire up a code space and have a Rust programming environment. You're also welcome to clone this down and make a copy of it or whatever, fork it, and set up your own little Rust environment with whatever configuration settings you'd like to use. And then you could explore Rust as much as you want, whenever you have time and you have a web browser, and you can do that. We've tried to set this up to make it very accessible.